Hi, this is Sheh. This video is for the homework 10, number 4 of first question, semi-random telegraph signal. Before we start to demonstrate the semi-random telegraph signal, we should understand what it is, what this special process is. This is a random selection of points with the density lambda. On the other hand, this is a probability of the getting k points in the 0 to t domain, in the t domain process. Okay, this is a Poisson distribution function. The probability of x of t equal to k e power of minus lambda t multiplied by lambda t power of k divided by k factorial. This is the regular one. So now we are talking about the k. This k. How we define this k is. This is in the time domain here from 0 to t. In this one, we have two categories. The first one is when the signal starts at 1, when the x of t equal to 0, we call it as a semi-random telegraph signal. However, when the signal starts either 1 or minus 1 at the x of t equal to 0, we call it as a random telegraph signal. What this talk about is when the signal starts at 1, when the t is 0, it starts at 1, then we call semi-random telegraph signal. If the signal starts either 1 or minus 1 when t equal to 0, it is a random telegraph signal. Okay, and let's get the example of this one. The stochastic process is defined as the x of t equal to 1 when k is even in the t domain 0 to t. If x of t equal to minus 1 when the k is odd number in the t domain 0 to t. So we start from the first one, this one. Probability of x of t equal to 1 in the domain x in the t domain 0. K is even, so k even, it means k is from 2, 4, 6, 8, 10, and go on. And then we sum up all the result of a probability as, and then it will become this one. So, and then we expand of this one, then we can get this one. So for the even value for the even value, you become e power of minus lambda t cosine h lambda t. That's a hyperbolic function. This is we can talk about the Taylor series even function. The Taylor series even function is when the even number, the value will become 1. Okay, this will become 1. On the other hand, if the Taylor series number is odd number, the last one will become negative. That's minus 1. Okay. This is 1, This is my last one. This one, my last one. So we can see there's different. These are number. Then this is even number. So then we talk about the even other number. The other number, same process here. Then we got the e over minus lambda t sine h lambda t. Okay. So now I'm going to introduce a formula about the hyperbolic function. The cosine h lambda t plus sine h lambda t equal to e power of lambda t. Cosine h lambda t minus subtract sine h lambda t equal to e power of minus lambda t. So what will be the expect value? The expect value x of t equal to 1 multiplied by even number, probability of even number, plus minus 1 multiplied by the probability odd number. So as this one, we can get the even number is e minus lambda t cosine h lambda t here. The odd number is e minus lambda t sine h lambda t. That's here. Okay, so we take the e minus lambda t outside of take this one. We take this one to the outside, so it will become e minus lambda t, and then inside here there's becoming cosine h lambda t minus h lambda t. Then we use this formula. Cosine h lambda t minus sine h lambda t will be e power of minus lambda t. So we become these steps. So this is multiply. So this will become e power of 2 minus lambda t. That's the expect value. Okay, now we are going to talk about the autocorrelation. In the autocorrelation, there are two scenarios. One is T1 greater than T2. The other one is T2 greater than T1. So let's get stuff from the T1 greater equal to T2. The autocorrelation value is expect value x of T1 multiplied by x of T2. So we expand this one, then we will get the same result. Okay, but here, remember here, there's a T1 minus T2 because there's this one, T1 is greater than T2. So that's why we here become T1 minus T2. So how about when the T2 greater than T1? If when the T2 greater than the T1, the autocorrelation value will become this one. We become same process here, and then here we become e power of minus 2 lambda T2 minus T1. So we combine the first T1 greater than T2 and the T2 greater than T1. We combine them together, they will become e power of minus 2 lambda absolute value T1 minus T2. That is the answer of the autocorrelation. Thank you.